Hey all, I'm going to show you a quick little video here of how to calculate your finest efficiency, E and V, correction factor, and all to find out your tons of sampled limestone per acre for your homework. So I already have the information for your percent passes for 8, 30, and 60 mesh. I have the CCE, and I've already calculated the ton of limestone needed. You can see my previous video on how to do that. They find the tons per acre on soil pH and the actual math behind this worksheet. So quickly to do this, let me go back here. You calculate how much you need for your 8, or how much gets stock in your 8 mesh, and that is since you start at 100. That's a hard value. You put that in there, and then you subtract it by that 8 mesh. You can enter values either two ways. You can either click on it like this, 84.3, and that will reference cell B2, or you can literally type that cell in B2. I would not just put this number in because that will just give you a value of 15.7. And if you want to use this later to calculate different problems, you'll not have this answer by just changing these over here. Then you continue to do that to calculate the 8 by 30, which you take the 8 mesh minus the 30 mesh, B2 minus B3, the 30 to 60, so that's the B3 minus B4, and the past 60 mesh will be just the value for the 60 mesh, which is B4. Now, in order to calculate the total finest efficiency, you would do the same thing you do down here, where you take that the values of the 8 mesh, 8 to 30, 30 to 60 times its factor, so 5, 20, 50, 100, and then you divide each by 100. I'm going to go ahead and divide everything by 100 at the end in my equation because it's easier and less to write in. So I'm going to go ahead and do an open parentheses, and you take that E2 value times 5, because that's the what gets caught in the 80 mesh, it's the first part, and then the F2 times 20, because that's what 30 gets caught in 30. Then you add it to the G2, which is the 30 to 60 mesh, and then you do it and then you add the 21.5 times 100, because that's what passes through. Then you close parentheses, and everything is divided by 100, which gives you a total finest efficiency of 41.35. Next, you calculate the E and V, which is your total finest efficiency that you just calculated, times your calcium carbonate equivalent divided by 100. So we have the calcium carbonate equivalent over here. So you basically do equals your total finest efficiency, which is I2, times your calcium carbonate equivalent, which is in B6, and then divided by 100, which will give you the E and V value. Now, to calculate the correction factor, you have the known value of typical limestone of 46.35, so equals 46.35, divided by this E and V value, which gives you your correction factor of 1.55. One of the advantages of using a spreadsheet is you don't have to worry about rounding errors. So when you go into tons of sampled limestone, you could take the value of tons of limestone needed, which is 2.5 tons in cell B7, and you take that times your correction factor of 1.15, which is K2, and that gives you 2.88, 86 and all that. So you know to get roughly 2.9 tons per acre. And then if you have to do other problems, you can change all these values. So 48, 37, and you can see how it changes it. You can change the CCE and see how it changes everything. If you have different tons of acres, you can see how that changes all that. So once you have this base in here, you can just literally change these numbers right here for the new problems, and it will give you the correct answer. I will upload this to D2L whenever you're done with your homework and it's turned in and graded, so that you can have this in the future if you wanted to. Thank you, and see you in class.